Alrighty, so I am solving question 13 from chapter 5 that asks the matrix A, given here, has eigenvalues -2, 2, and 4. And to find the corresponding eigenvectors to these eigenvalues and to form the matrix P that gives the equation A is equal to P inverse times dP. And so to do this, I'm going to find the null space of A plus 2i, A minus 2i, and A minus 4i. And by finding these null spaces, the vectors within the spanning set are going to be the eigenvectors for these given eigenvalues. And so that comes from the equation A minus lambda I. And so to start, A plus 2i is equal to 3, -1, 2, -1, 3, 2, 4, 2, and 2. We can see the reduced row echelon form of this matrix. It's going to be 1, 0, 0, 0, 1, 0, 1, 1, 0. And we remember from what we learned about taking the null space, we want to write it in terms of the free variable. So we're going to subtract, and we need to remember that we need to put the 1 here because we're multiplying by x3. So we're going to say that the null of A plus 2i is equal to the span -1, -1, 1. And so we can say that this matrix right here is the eigenvector for the eigenvector -2, because we plugged it into this equation to find the null space of that. We see that it's +2 because of the negative. And so for sake of time, I'm going to go a little bit faster on the next two. A minus 2i is equal to -1, 1, 2, or -1, my apologies. -1, -1, 2, 0, 2, 2. The reduced row echelon form of this is 1, 1, 0, 1, 0, 0, 0, 0, 0. And from this, we can see the null space of A minus 2i is just the span of -1, 1, 0. And so that's going to be the eigenvector for the eigenvalue of 2. And then quickly we can go minus 4i. A minus 4i is equal -3, -1, 2, 2, -2, -3, 2, 2, -1. Sorry, I'm saying these numbers out of order, so it may be a little bit confusing if you were just listening. The reduced row echelon form of this is going to be 1, 0, -1/2, 0, 1, -1/2, 0, 0, 0. And same intuition as before, we can say the null space of A minus 4i is going to be the span of 1/2, 1/2, 1. And so for these three corresponding eigenvectors, or for these three eigenvalues, their corresponding eigenvectors respectively go as such. And then to satisfy this equation, we just can create a P out of our eigenvectors in the order of our eigenvalues as we found them. And we can just say that P is equal to -1, -1, 1, -1, 1, 0, and 1/2, 1/2, 1. And that P will satisfy A is equal to P inverse D times P.